What's going on, everyone? Steven here from Techmaker Studio. In this episode, we're going to keep going with our generative NFT project. We're going to basically start by just hooking up the full functionality of our NFT contract so that you can actually buy up to 10 at a time. And that'll probably be all of this episode. Hopefully, it'll be a little bit quick. And then in the next episode, we're going to start pulling in the images from our API server that we started building that's integrated on top of Aleph. So that's kind of where we're headed. Let's go ahead and jump in. So the first thing that I want to do is add a list of all of the previously purchased NFTs to the screen. And the reason for that is because let's say we buy 5. I want to be able to easily see like, okay, we bought those 5 and we own them. Okay. And in order to do that, we actually are going to need to add a function to our contract. So we'll do code dot if you're using VS Code, and obviously you're going to need to have been following along with some of the previous tutorials to kind of have a sense of what's going on here. But we're going to make one small change to our frog contract. We're just going to add a function, and you can see here that we have in our I guess we never actually added the requirement. Oh yeah, max mintable. Here we go. So we have this max mintable function, or value rather, and I think when we start we're doing 20. So we could in theory use this as saying like, all right, what's the max, and then like count all the way up to that number, but I don't want to do that. What I want to do is actually have like function current supply, and this will be public view returns uint 256, and all I want to do is say return token IDs dot current. So essentially, before anybody has minted anything, we'll have 0 as our current supply, and then as people go, obviously it's going to mint whatever number they mint, and then we'll have that show up in the interface. Okay, cool. So that's literally the only thing I want to do. This isn't supposed to be a smart contract episode, so I'm going to shut this down. I'm going to come over here and I'm going to go truffle deploy reset, which should bring me back to basically 0 on everything. In theory, here we go, compiling. All right, so that's done. So now we can change down into our client, npm start, and we should be good to go. And again, if you're missing context for this video, be sure to catch the previous ones. I'm going to make a big playlist. So, okay, now everything's loading again. Let's go back to our code. And again, sorry I had a couple of different directories open. I'm kind of bouncing around a little bit. So when we, okay, component did mount, we're getting Web3. I haven't really done much yet on querying. So what I need to do is say, and I'm so used to the function syntax now, I'm not planning on doing a lot of customization to this, honestly, or else I would just redo the whole thing with the new React function style. But what I want to do is say const current supply equals await, and then we'll do instance dot methods dot current supply dot call, and I'll need to parse int on this, and then I'm going to go ahead and set that in my state as current supply. Okay, let's just save that and see if it actually didn't type parse correctly. Okay, so now we're loading. Let's go ahead and come down into our code inside of app, and I'm just going to put a p tag and say current supply, and then this.state.current supply. And let's close off our p tag here, and we should have a 0. Cool. All right, so let's make sure this is working. So I'm going to go ahead and mint one frog, and I can just confirm. And now I should have to refresh actually because we don't have that hooked up. Cool. So now we have a current supply of 1. We mint a frog again. We should get 2. Cool. So it's definitely hooked up. So I wasn't going to worry about this in this episode, but then I just did a quick Google for WebSockets with Ganache. And I think let's go ahead and try this. So basically what we want to do, so we have this local host. I think ours is 7545, right here. I think we might be able to just talk to this really quick. So what I want to do is just copy this line and pop back over into our React code, and just under where we set up Web3, let's do const Web3 socket equals this. And let's change this to 7545. And then down here, we can do, and again, we're creating kind of parallel pathways here, which, maybe isn't the best way to do this, but let's do a socket instance. And we're going to do is Web3 socket, and then basically the exact same thing. And then let's see. I think we can listen to all events or something. What did they do here? Here we go. Yeah, contract events, all events. Let's just do this. Let's just console log. Let me paste this in here, and then we'll do socket instance dot all events from block 0 function error event. Okay, cool. So it's basically just logging out whatever we get, we log it out. So let's come over here. Web3 is not defined. What do we do in get Web3? Just like that. We want to do that. Put that here. Okay, cool. So I'm going to open up my terminal. And we have 3 objects being logged out, which I assume is coming from the socket. Let me just come over here to be sure. So we'll do like that, just to let us know that it's actually coming from the socket. Cool, so these are coming from the socket, so that's coming in correctly. Cool. Okay, so let's try to basically just listen to transfer events. So there we have that. So now we get just the 2 events coming in. And let's see, what else? Basically what we want to do, let's see, what is this right here? Console.log this. What do we get? I think that's that, right? Console.log this, we get A. What is A? Is that just like an anonymous function or something, or what? Maybe it's the event. Maybe we're inside the event, potentially. Because I can see there's a lot of blockchain-related stuff attached to this, it looks like. Yeah, so this must be that. I don't know. So what we need to do is actually, when this happens, we need to update our state. So normally, what we would do is say, this dot state dot whatever, right? This dot set state even. But as we just saw, this is not the component down inside of here. We're actually probably inside of the event, right? So what if we do this? What if we say const, and then we say, well, let's see. The first thing I want to do before we kind of get ourselves really confused, let's move this stuff up above. So at this moment, what's in our state is the Web3, the accounts, the instance, and the current supply. So now if I say const, let's do component state equals this dot state right here. Then down here, let's do component state, and let's just see what we have. Okay, and now you see we've got all the stuff inside of our state that we would normally have. If we just logged out this, you saw we were in the event. And I think if we actually don't put these in this order, then basically this gets set basically like via closure. So it will have whatever is in here at the time that it's rendered, which may actually cause us a problem and it won't work more than once. So we'll see in just a second. We don't need this console log here anymore. We don't really need this console log. So what we want to do is essentially, well, we want to get the current supply, right? So if we put this down in here, we'll get an error because it'll say you can't await outside an async function. So maybe we can actually just make this async. Is that possible? That does seem like it worked, bizarrely. And then what we want to do is this dot set state. Well, what we want to do is say component. You know, in actual fact, I don't want it to say component state. I want it to be component. Let's actually console log component really quick. Component.state. This is kind of taking a weird turn here. So that did not work. So if we say component, let's try it might be a reserved word or something. And this should be this. No, actually, that was my bad. That should say component. I like that better. And then let's do component.state. Okay, cool. So now what we should be able to do is say underneath this current supply, we should be able to do component.set state and then pass in just the current supply. Let's try this and see what happens. Okay, so let's mint a frog. Let's confirm. And let's see if anything happens. No, it does not. Let's console.log again. Okay, so we get here 3 times. Let's mint another frog. Okay, so we do get here, but we don't get anything happening on the screen. Okay, so that's no good. Okay, so why don't we actually console log the current supply as well. Okay, and then we'll mint a frog. And did we still get 4? It looks like we still got 4. That's pretty strange. Huh. So on the second time, it actually works. So now it looks like it's working. That's kind of weird. I wonder why that's happening. So if we refresh, does it go to 7? Yeah, so it's counting 1 behind. So the only thing I can think is that this callback, making that async, might be an issue. But then we won't be able to await here. I guess what we could do is basically do make this like a promise dot then result, and let's do result equals parse int result, if I can spell, parse int result. And then let's console.log result. And let's start with that. Okay. So I'm just going to refresh, mint the frog. Nope, still got 7. And if I refresh, I'm at 8. So I'm not sure exactly what's causing this, to be totally honest with you. It could be a timing thing. It could be a number of things. But what I'm going to do, I think, let's console log the event itself. This is going to be kind of potentially a little hack, but like, let's look at the actual return values. So essentially, the event has a few things. So the 0, in the case of this transfer, is going to be the address it was minted from. The 1 is the address it's minted to, so it's basically transferring from the 0x00 address to the address we purchased with, which represents a minting process, basically. Then we have, I believe this is our token ID in 2. Oh, actually, no, you can actually see them all here. Just kidding. So from 2 and token ID. Just need to look down a little bit. So I was going to talk to the second thing, but I think I'm actually going to just call it .token ID. Let's console.log. Let's actually do this. Let's get rid of all of this. So we have our component, right? Let's console.log event.return values.token ID. So here we have 1, 2, 3, 4, 5, 6, 7, 8, right? What we can do is go ahead and set the state. This is going to be kind of weird. What we could do is this. We could say if parse int token ID. Let's say this. It's kind of a bizarre way to do this. Let token ID equal. This is why this is a workshop and not a tutorial. It's because this is kind of just working through stuff to try to figure things out. Okay, so we're going to say let token ID is that if parseInt token ID is greater than parseInt current supply, then component set state token ID. Current supply is token ID. Okay, so we start out with 8. Let's mint a frog. And current supply is 9. Cool, so a little bit hacky, but when we refresh the page, we're relying on that actual the actual count that we added to the contract at the beginning, that method, and then now we're actually just pulling it from the token ID in the event. So that's pretty handy. Okay, so one thing we should mention about the limitations of this way of doing it. First of all, this would work perfect if you could actually do this from block 0, because then it's going to play back all the events from the beginning of time. But on a public chain, this is super impractical. And you wouldn't want to rely on this. We'll probably end up being like from block latest minus 1,000 or something. So just like the last 1,000 blocks or even less. I don't know. This will work fine for this sort of like listening to live events as they come in and updating what's on the screen based on it. But we won't be able to do anything other than that, really. I think I'm getting a little bit ahead of myself. I was thinking about something and I started explaining it before I had said it. What I was imagining we might do, because what I'm looking at in the console, well, I'm not now, when I was console logging out all these events, which we can still do. So you can see actually we have all of these transfer events printed out. So I had the idea off camera that what if we actually just took these events and printed them out on the screen but formatted them in a table, and then we could say, oh yeah, when we mint a frog, you can see it add to the screen. And that would make sense, except for we won't be able to load them all into the table forever because like the chain just has too much information. Right now we're running on a local chain that's just our little app on it. On a public chain, there's no way this would work. So what we need to do what we're going to do is actually take this current supply and we're going to say, okay, if we know there's 9, right, that means we have IDs 1 through 9 based on how we program this. So we're going to say for every single one, let's query who owns it, and then let's put that in a table. So I was going to do that in this episode and then got totally sidetracked by this socket stuff, which didn't go quite as planned, but that's how it goes. So I think I'm going to do that in the next episode, which I'll probably do today just after I finish this. But hopefully you made it all the way through this. This is kind of interesting. It's kind of why I want to do. I'm moving into splitting up between like these short tutorials versus like workshop stuff where I just kind of work through it and I kind of freestyle for the most part, because that's kind of more my thing and it's kind of how I like to do it. And if you made it this far, hopefully it's interesting and helpful, and I'll talk to you in the next one.